So this Euclid, do you remember his name? Have you seen it before?
Yeah.
Okay, yes, a very famous mathematician. And in algebra, we learned a theorem of Euclid that there are infinitely many prime numbers, the same Euclid. Okay.
Yeah.
So here, postulate is something kind of the hypothesis or axiom. Also use axiom, hypothesis. It's the first one. They are very simple ones, but the foundation of the geometry. We have this through any 2 points, there is a unique line.
Yeah.
Okay, very simple. The first postulate one and only one. Second postulate, given any straight segment, we can extend this on both sides indefinitely to get a line.
Mhm.
So it means any segment So this is a little bit abstract. Later we will see why they are important. So first we learn all 5 of them. The third one is given any point, any radius, we can draw a circle. Any point, any positive number. The third one about circles. So given any point, any positive number, we can draw a circle with this as center, this as radius. This one, all right angles. Okay, they may have a different position. We have one right angle here. One right angle there. Another right angle this way. They all have the same measure, even they have different angles. Fifth one. Fifth one, we consider 2 lines, not necessarily parallel. Okay, we consider the two interior angles on the same side. We can consider this one. The fifth postulate states that if the summation of the two is less than a flat angle, then the two lines intersect on the same side. Okay, for this one, we will have, if we extend this a little bit, we find the intersection. Okay, so these are the five postulates. They're the foundations for the geometry we are studying. Because of this, we name our geometry the Euclidean geometry. So the geometry based on the five postulates. So Euclidean geometry. Okay, first we will have some consequences. That's what happens when this condition doesn't hold. What happens if the summation of the two angles is bigger than 180? Let me draw another picture. Okay, Samuel.
Yeah.
So if the summation is less than 180, then the two lines intersect on the same side. What
Yeah.
happens if it's bigger than 180?
Then it shouldn't intersect, right?
So let's see, in this case, the conclusion is, let's see, what is a different color? What happens to these two interior angles?
Or they intersect.
Okay, so the summation of these two is 180. Summation of these two, another 180. The summation of these two is bigger than 180. So the summation of these two will be less than 180. Okay, is this clear? Okay, Samuel, explain to me why it's less than 180.
Well, because like since in the one before for P4, like Like they basically just turn the diagram, like they flip it. So in P5 actually, sorry, like
Uh-huh.
in P5, like they basically just flip it over cause
Okay. Uh-huh. Okay.
like
So
yeah.
that's the geometric part. If we flip this over, we get this picture.
Yeah.
Okay. But here we give a algebraic argument. Why this is less than 180? Because what's the summation of these two angles?
Well, that equals like L2 plus L4.
No, let's see. This is first angle, angle 3. If we add them, what do we get?
We get angle 2 plus angle 4.
It is, but what is that angle?
It's wait, 180?
Yes, because the flat angle, so this is the 180. As you have mentioned, this is the same 180. So if we add them all together,
Yeah.
okay, what's this?
Well, then it should be 360.
360. Now we want to estimate this pair to be the difference.
So it must be smaller than 180.
Because by the assumption this two is bigger than 180, the subtraction to be less than, which is 180. In this
Yeah.
way, we prove that the summation of these two is less than 180. Okay, after this proof, we can see we can buy the fifth postulate. Because the two is less than 180, then the lines will intersect on that side. So these two lines will intersect on that side. Okay, question about this part.
Yeah, I can understand this part.
Okay, cool. Okay, now let's put them together. So if it's less than 180, it intersects on the same side. If it's bigger than 180, the two lines intersect on the other side. What happens if it's equal 180? What can you say about the two lines?
Well, then the two line
Mm-hmm.
intersect. Wait, no,
Okay.
no, no.
Uh-huh. If the two equals, let's see, one example it will be,
Then yeah, then it could be like that, like it's perpendicular to each other.
okay. So okay, in this case, the summation of the two angles equals 180. It's not small, not less than 180, so it does not intersect on the other side. No,
No,
not a bigger, so it does not intersect on that side. The two lines do not intersect. Okay, there's three cases. Okay, the first case, in the definition of this fifth postulate, if it's less than 180, it intersect on this side. If it's bigger than 180, intersect on the other side. When it's equal 180, they do not intersect. Okay, so this is why the fifth postulate is also called the parallel postulate. So here we see the two lines do not intersect. They are parallel. This is the one. Our fifth postulate is also called okay. Sometimes we say it's the fifth postulate. Sometimes we say it's the parallel postulate. They mean the same thing because it tells us when the two lines are parallel. It's when the summation of the two angles on the same side is 180. Okay, now we will give some consequences. So corollary. We use the notation L1 parallel L2. Okay, so we have a notation over there. So the two lines are parallel. We use this to indicate the two lines are parallel. Okay, let's see how to prove this. Have two parallel lines, have a transversal Okay, so let's refresh your memory. Which pair of angles are corresponding angles?
5 and 4.
5 and 4. So let's recall what's the definition of corresponding angles?
Oh, it is supposed to be like on the same line, right? Like 8 and 1.
Okay, corresponding angles. That's partially correct. Corresponding angles will be at different vertices on the same side, one interior, one exterior.
Mm.
This time it will be 1 and 5. Okay, are there other corresponding angles? Daniel?
Yep,
Uh-huh.
then it's 2 and 6.
2 and 6. So again, 2 and 6, different vertices, same side, one interior, one exterior. Okay, two more pairs.
Well, also 3 and 7
Mm-hmm.
and 4 and 8.
Okay. Okay. So the corollary states that if the two lines are parallel, then the corresponding angles must be the same. So we want
Yeah.
to prove. Okay, can you tell me why they must be the same?
Well, because like, well, because the line is like, uh, it's like the same distance.
Okay, so let's see how we prove this. The two lines are parallel. What can you say about the summation of these two angles?
They're the same. Oh, okay. Oh,
What can you say about these two angles?
well, they are the
What's the summation of them?
just be
We can go to the
uh
previous statement. So if this is
oh,
uh,
it should be 180, right?
okay, yes, this is the 180. Okay, now what can you say about this summation? Angle 5, angle 8. What's the summation? Samuel.
It should be 180 again.
Okay, yes, why? Correct? Why?
Well, since they're basically on the same line and like
Okay,
the
so
angles are the
this
same.
is called supplementary angles, since they are supplementary angles. Okay, this one is by P5. Okay, the two angles, 1 and 5, they both add the angle, same angle, they get the same angle. What can you say about these two? Are they the same?
Well, then they are the same.
Uh-huh. Why? How do you
Because
convince
like
others?
they both equals to 180, like if they plus together. Well, that makes them the same.
Okay, so because angle 1 is 180 minus angle 8, this is the same as angle 5. Okay, this way we complete the proof. I will put a square over there to indicate we finished the proof. Okay, so that's our first corollary. If the two lines are parallel, then the corresponding angles are equal. 1 and 5, same. 2 and 6, also the same. Second corollary. Again, let's assume L1 parallel L2, then the alternate angles. Okay, now let's try to refresh your memory. What are alternate angles. Do you remember the definition of alternate angles?
Not really.
Okay, so it's close to this one, at two different vertices, but on different sides, both interior or both exterior.
Oh,
Okay, if I give you angle 1, could you find the alternate angle for angle 1? Different vertex should be here, different sides should be 6 or 7. Both interior or both exterior. This one's interior. Which one is interior, 6 or 7?
yeah, it's 6 or 7.
Which one is interior?
7.
7. Okay, so now we see 7. Okay, so these two angles, 1 and 7, different vertices, opposite side, both interior. A pair of alternate angles. Okay, let's find three more pairs. If I give you angle 2, which pair?
Well, I would say it's pair and 8
8. Now I give you angle 3.
and 3 and 1.
Okay, different vertices,
Oh,
different sides, and both
5.
okay, 5, both exterior. Angle 4. Angle 4. So different vertices should be there, different side, both exterior.
Well, 2.
Different vertices.
Oh my God, it's 7. Wait, no, 6, 6.
6. Okay.
Yeah, I was
So
lagging.
yeah, so the three requirements, you check them one by one. Okay, so these are the alternate angles. Now we want to check, are they the same?
Well, yeah. I mean, it doesn't really make it like all the same.
Okay, are they equal, angle 1 and angle 7?
Yeah,
Why?
because they're the same interior angle and if we do like angle 7 plus 2 it's gonna equals 180. Well,
Uh-huh.
if we do angle 1 plus 8, it's gonna equals 180, so it makes sense.
Yes. Okay, so this is a direct proof. Very nice. Okay, so first, angle 1 plus angle 2, 180. Because this is the flat supplementary. Then angle 2, angle 7. Since the two lines are parallel by the P5, the fifth postulate. Therefore, to angle 1, 180, Okay, so this completes the proof. Okay, any question about these two corollaries?
No question.
Okay, so now not only we know they are they equal, but we also know why, followed from the postulate. Okay, let's give a summary of what we just proved. The summary. Transversal. Okay, so that's the picture we have in our mind. Okay. Then the following are equivalent. First one, the two lines are parallel. Second one, the sum of the two interior angles on the same side. Okay, the parallel postulate. Third one, the alternate angles. We start with corresponding. Okay, we have a summary of what we have just proved.
Yeah.
Two lines are parallel. The summation of two interior angles on the same side. Summation of this two will be 180. Summation of this two will also be 180. Then the corresponding angles are equal. This one and this one, the corresponding angles, they equal this one and this one, this and this. The alternate angles are equal. This pair, this pair, this pair, this pair. So one is true, then all three are true. Okay, so that's the summary. Next, we will deal with triangles. Okay, how do you describe a triangle, Samuel?
Well, it's either like a obtuse triangle or obtuse.
Okay, there are different types of triangles.
Yeah.
In general, with 3 points, 3 sides. So instead of 3 points, I will draw 3 lines.
Yep.
Okay. I call it three vertices, A, B, C. Let me put A on top. Three sides.
Good.
What are the three sides for this triangle?
Well, it's angle ABC. Or yeah, you already
Three
said it.
sides.
It's AB,
Uh-huh.
CB, no BC,
Uh-huh. That's okay.
and then AC.
AC. Okay. And I have three angles.
Three angles like 1, 2, 3. Just do that.
Okay. Okay, that works. 1, 2, 3. So these three, we call them interior angles. We also have three exterior angles.
That's
Okay, I'm going to label them A. So this will be this one, and this one. So I will call this alpha, so this beta, this gamma. So three exterior angles. Okay, so the geometric objects for triangles. Now
yeah.
some theorems. First theorem, I claim the summation, the sum of three interior angles. What, okay, what can we say about the sum of 1, 2, 3?
Well, it's equals. I don't think equals 360, right?
It's not. It's another special angle. It's close related. This is 180.
Oh,
Okay, theorem 2. The sum of the three exterior. Okay, if we add alpha, beta, and gamma, what's this summation? Is it still 180, Samuel?
no.
No, it's bigger.
Yeah,
So
it's probably gonna be like
yes,
No.
360. Okay. All right. Now let's see why. Why the sum of the three is 180? How do you justify this?
Because like obviously it's not gonna be like I don't know how to say it.
Okay. I will recreate the picture. I will recreate it over there. 3 lines. You can draw 3 arbitrary lines on your book. 1, 2. Don't have to be the same as mine. Anyone works. Okay, so I will 1, 2, 3. Okay, I will create another line that is parallel to that edge. So I call this A. Okay, my B and C is flipped. That's okay. B, C. So this line through C and parallel AB. Okay, so we draw another line through the vertex C and parallel to AB. Now we want to check this angle. Angle 4. Angle 4 and angle 2. What can you say about these two angles?
Well, it's similar.
So they are alternate angles, right? So angle 2 and angle 4 are these two lines, they are parallel. So the alternate angles are equal, right? Do you agree or not? Okay, any questions for this one? Why these two angles equal? Samuel, what's your answer to this?
Well, I would say they're equal.
Why?
Well, because they're alternate angles and like they should equal 180 when you plus it.
Okay, if you plus this angle with 4, 180, plus this angle with 2, 180. So 2 and 4 must be the same.
Yeah, exactly.
Okay, now let's see another one. Angle 5. Now I claim angle 1 and angle 5. What can I say about these two angles? Samuel?
It should equals, let me think. Still 180, right? Because it's still alternate angle is equal to angle 2 and 4.
Okay, so these two angles, again, they are alternate.
Yeah.
What can you say about alternate angles or parallel lines? 1 and 5. If we go to the previous summary, when two lines are parallel, the alternate angles are equal, right?
Yep.
Okay, okay. Adjust the camera so I can see your eyes. I can only see your forehead.
What? The camera?
Okay, adjust the camera. Maybe you lower it a little bit. Okay, okay. So
You can see
this,
what's on here, right?
no, I cannot. Let's do
Well,
okay, to
I'll
angle
just do it
1.
like this.
Okay. Okay, now we want to find the summation of the three interior angles. Okay, the first one, angle 1 is angle 5. They have the same measure, so I can replace 1 by 5, right?
Yeah.
Angle 2 and angle 4, same measure, replace 2 by 4. Then angle 3. What can you say about the summation of these three angles? 5, 4, 3.
3, 2.
Hmm?
Yeah.
What's the summation?
Equals 180 plus, wait, let me think. Plus 90?
Just 180. So it's a flat
Oh,
angle, just 180. So in this way, we conclude the sum of three interior angles of
yeah.
any triangle is 180. So that's our first theorem. Okay, our second theorem, the sum of three exterior angles, 360. I say, why is
Yeah.
that? This is proof of theorem 1.
Yeah.
Now proof of theorem 2. Proof of theorem 2, again, I will draw an arbitrary triangle. Your drawing don't have to be the same. Okay, I will label the vertices A, B, C. The three exterior angles. I used alpha, beta, gamma. We want to check 360 and 160. Why? Okay, so before we start, I want to check with you if I have a whole angle. What's the degree of this angle?
Well, the angle should be 360.
Okay, so this is 360.
Yeah.
Okay, let's check if the three of this add up to a whole angle. So we will start from, let's start from here. Use different color. Okay, this is our starting direction. First step, we add beta. So our direction changed to there. Our initial direction, first turn. So imagine we are walking along the sides of the triangle. We want to see how our direction changes. So from there, we make a turn to that direction. We had one angle beta, right? Then we keep walking on this side, and this vertex we make another turn from here to there. Then the second turn from here to there. Again, we walk along the side. At the third vertex, initial direction, we make a turn to this direction. So we complete a loop. Samuel, okay, maybe you can describe this process, what we just did.
We basically just like try to like prove like why like when you spin it equals 360.
Okay, so what we do is we walk along the side of this triangle. Initial directions from there, we make one turn of angle beta, another turn of angle gamma, another turn of angle alpha, then we return to the initial direction. Okay, let's see what happened. Initially it was over there. We make one turn. Beta. We make another turn. Gamma. Third turn, we return to the initial position. So we start from here with the 3 turns, we return to it. Therefore, the summation of the 3 is the total angle, the 360. Okay. So if we walk along this, we want to check how our direction changes. We go that direction, then we make a turn of angle beta. We go this direction, we make a turn of angle gamma. We go this direction, we make a turn of angle alpha, we return to the initial direction. So we make a full turn, it is 360. Okay, so this proved the second theorem. First theorem, interior angle 180. Second theorem, exterior angle 360. Okay, question about this too, Samuel.
Not really.
Okay, now we have proved both, and I want to show you that these two are equivalent. The one follows from the other. Okay. A second proof. I will draw the picture again. So I have 3 interior angles. 1, 2, 3. 3 exterior angles. Alpha, beta, gamma.
Got it.
What's that, Samuel?
Nothing.
Okay, so now let's check angle 1 plus angle alpha. What's the summation of these two angles?
Well, that is 180.
Nice. 180. Angle 2, angle beta. What's the summation?
180.
Another one. Now if we add them, another 180. Okay, if we add all of them together, so this 1, 2, 3, the summation of three interior angles. Alpha, beta, gamma, the summation of three exterior angles. Summation of this, three times of it. Okay, so summation of, right? Okay, now if this is 180, then we do the subtraction, this must be 360. If
Yep.
we know, yes, Samuel, what's that?
What?
So if we know this is 180, what can I say about this?
It's 182.
No, it's not.
Oh yeah. It's
Uh-huh.
2.
Two times it,
360,
yes.
right?
Yes. Okay, now if I know this is 360, what can I say about this one?
Well, then that's 180.
Yes. So this means the two theorems, one and two, they are equivalent. If we can prove this one, then this one follows from this identity. The summation of all of them is three times of it.
Yep.
Okay, so the two theorems, one, okay, interior, one exterior. Which one do you prefer? Which one do you like better?
Oh, well, that's because it's an alternate angle, I guess.
Okay, I mean, so these two theorems, which one do you prefer? Which one is the more,
Theorem
uh,
1.
theorem one, why?
Because I thought it's easier.
Okay, the interior. Okay, now let's see what happens if we allow four edges.
927计数。
Okay, so we have four interior angles.
Wow.
One, two, three, four. And the four exterior angles.
Yep.
Alpha, beta, gamma, theta. Okay, now I claim the summation of the three interior angles. Summation of the four exterior angles. Okay, so this will be the same, 360. The summation of the exterior angles doesn't change, but the summation of the interior angles changed. Previously, for triangle is 180, but for this quadrilateral, it will be 2 times 180. Okay, let's see why. Again, we start from here. Let's imagine we are walking along this. It's a different color. Okay, so initially we are walking in this direction. At this vertex, we make a turn. So from there, we turn to that direction. We turn alpha. Samuel, is this step clear?
Yeah.
Then we keep walking. At the second vertex, we make another turn, angle beta. Keep walking over there, another turn, angle gamma. Keep walking over here, another turn, angle theta. Then we return to the initial direction. So what happened here is we start from here, we make a turn, alpha, make another turn, beta, another turn, gamma, another turn, theta. So after 4 turns and at the vertices, we return to the initial direction. So we return the initial direction. Therefore, the summation is a total angle which is 360. What do you think of this proof, Samuel? Is this similar to what we had before?
Yeah, pretty much.
Pretty much, yes. So we can say for the exterior angles, the proof for triangles, for quadrilaterals, they are very similar. But for the interior angles, the proofs are different and the result is also different. So in this sense, we see the summation of exterior is more, maybe more geometric, more important. So now we can have n polygons. Okay. Have you seen this term before, polygons?
Yeah, I've seen it.
Okay, what does it mean?
Like the interior angles of it.
Okay, so polygons, they're generalization of triangles or quadrilaterals will allow any number of edges. If n is 3, it's a triangle. If n is 4, quadrilateral. N equals 5, n equals 6. So this is a general name. Then we have the same proof about the exterior angles, the summation of. Okay, so no matter how many sides we have, the 360. Then the summation. Okay. The proof is similar to the n minus 2, 180. For example, if n is 3, if n is 3, n minus 2 will be 1, so it's 180. That's for triangles. n equals 4, quadrilateral. Okay. A particular case is our rectangle.
Yeah.
So this one we can say the summation of the interior angles is twice of 180, so it's 360. The interior angles. Okay.
Yep.
Next, we will study this congruence.
Wait, what time is it now? Is it like, what time is it?
It's 4:05,
Oh,
4:05.
well, when does,
We're done with stop. We stop maybe 25 minutes.
oh, okay.
Okay. So congruence, the congruent. Two geometric objects, they are congruent if after some translation, okay, congruent. In particular, we apply this to triangles. So we this triangle, A, B, C, E, F, G. I will use this for a triangle. Triangle A, B, C. Triangle E, F, G. And we say they are congruent. They are congruent if the following 6 conditions hold. A, B, and E, F. These two sides have the same length. Similarly, B, C, F, G, A, C. each pair has the same length. Angle A, angle B, angle C. Okay, this is what we expected. Two triangles, they are congruent if the three pair of edges they have the same length, three pair of angles the same measures. Okay. So here, pay attention to the order of the triangles. How do we order the vertices? If we switch the two, it will be a different condition. Okay, Samuel, what's the difference between these two triangles?
Well, is it because like the angles are not exactly the same?
They're not the same order. So here with FG, this GF, the order changed. We view them as two different triangles. In particular, ABC, EFG, ABC, EGF. These two conditions, they are different. If we change the order of one of them, keep the other one fixed and changed, then this will give us a different condition. Okay, so we want to check when the two triangles are congruent. We don't want to check all 6 conditions. The following theorem says we only need to check 3. It's called the side angle side theorem. So we will use this SAS for short. Sometimes we just say SAS theorem. Okay, suppose the two triangles the following condition. Suppose the two triangles satisfy the 3 conditions. Equal sides, equal sides, equal angles, then they must be congruent. You can compare with the definition. Definition have 6. Here we have 3 of them. So if we, let me draw the graph. A, B, C, E, F, G. Okay, the first condition, A, B, E, F, same size. Second condition, B, C, E, F, G, same size. Third condition, this angle, same measure. Then the two triangles must be congruent. How do we prove this? We can move this vertex over B, while put this side on top of B and C. Because they have the same length, so the G will be on top of C. The same angle. So this edge will be on top of this edge. The same length, they both start from this point, so E will be on top of A. So we have a translation. You can translate this over there, equal edge, equal angle. Then the 2 points, they coincide, so they must have the same length. Okay, what that means? So this is the proof. Super.
Yep, understands it.
Okay, so this superimposition. If we place F over B, this line over this line, because they have the same length, so G will be on top of C. Same angle, this one will be on top of AB. So E will be on top of A. G on top of C. In particular, the two sides are the same. This implies
Yep. God.
so we have verified all 6 conditions. This implies the two triangles are actually congruent. Okay, what do you think of this, Samuel?
What?
This proof. So why the two triangles are congruent, even though we only assumed 3 of the 6 conditions. But we
Because
can
like if you think about it, like even though it's not the same, but it can still like symbolize like
Okay, so the point is how to make your argument more rigorous. It's not just, oh, okay, I know it is, I can explain why it is. So here we use this method, superimposition. If I put this on top of this one, then C and G coincide, E and A coincide, the two sides must be the same. The two angles must be the same. So we have 6 conditions. They are congruent. Okay, any question about this part? Any other questions? Okay, so if no, then you can start working on this week's homework. Homework 7. You can try the homework
Okay.
7. Okay. So this is what we covered yesterday. So you cover this, then you can, the next week you can be in the same schedule as we have in class.
Okay.
Okay, cool. Okay, we stop here today. Okay, see you next time.
Thank you.
Okay.